Good morning, students. In this session, I am going to discuss the next topic, that is called the change in entropy. Let's start the change in entropy. Change in entropy change in entropy is independent of path. So let's how can we find out the change in entropy? So change in entropy is S final minus S initial, final work or initial work. So, or we can write here S product minus S reactant. So, by the difference we can calculate the change in entropy. What is the relation between change in entropy heat and temperature? Delta S is called change in entropy, as we have already discussed in the previous video about the entropy. Q, that is called the heat change, heat energy, not change, heat energy either evolved or absorbed, and T stands temperature, and we taken the temperature as constant temperature. So in a reversible and isothermal, so in a reversible and isothermal process at constant temperature, if Q is the heat energy, then change in entropy equal to Q reversible by T, or we can write change in enthalpy by T. This makes a one equation. And SI unit of change in entropy is joule kilo Kelvin inverse mole inverse. This is the unit of change in entropy. So total entropy change means for the system and surroundings, of a spontaneous process become del S total equal to change entropy system plus change entropy surroundings is greater than 0. So note down one thing: when a system is in equilibrium, when a system is in equilibrium, the entropy is maximum. Equilibrium, the entropy is maximum. More randomness of the molecules. So when a system is in equilibrium, the entropy is maximum, and the change in entropy is 0. At equilibrium there will be no change in entropy whether the system at in the equilibrium, but entropy is maximum when the system attain the equilibrium. So let's discuss entropy change during expansion and entropy change during compression. So let's discuss about the entropy change during the first case, expansion. In case of expansion, an isothermal system is isothermal and reversible. Isothermal and reversible. Means temperature means T is constant and heat energy Q in case of expansion absorbed. So change entropy of system becomes Q reversible by T means temperature, and change in surrounding, change systems and change in surroundings. We consider surrounding as a reservoirs also. So I can write reservoirs. In some book reservoirs is mentioned instead of surrounding. So it becomes minus Q reversible by T. So what happened? So entropy, change in entropy total becomes system plus surroundings minus Q reversible by T. So it becomes 0 in case of expansion. So let's discuss entropy change during compression. What happens? Let's see. In case of compression, of system, Q reversible, just reverse the sign of the system, and change entropy of surroundings, or we mention here reservoirs. So it becomes reversible by T. So let's calculate total entropy. Total entropy system in change entropy of system plus change entropy of surroundings means reservoirs, Q reversible by T. So it becomes 0. Thus total change entropy, this total change in entropy in completing a cycle, equal to change expansion total entropy change in expansion plus total entropy change in compression, means this comes 0 this comes 0, that means it becomes 0. So entropy, change in entropy is 0. So change in entropy is 0. So it is a state function. So we can say that it is a state function. State function means it depends only the initial and final value. In case of reversible, we already discussed what happened. But in case of irreversible, note down, for irreversible system or process, or irreversible process, change entropy, total change entropy means change system and entropy change in surrounding not equal to 0. So remember it in case of irreversible system. Let's discuss the entropy change in phase transformation. Next topic is entropy change in phase, solid, liquid, gas, sublimation, evaporation, condensation, phase transformation. First, entropy of fusion. Entropy of fusion, change in entropy of fusion. It is equal to the change in entropy when 1 mole of a solid changes into 1 mole of the liquid at its melting point. So solid changes into liquid and liquid again changes into solid. So we can say that change in entropy, fusion, entropy change in fusion is liquid minus solid, final minus initial. So we can write here it equal to change enthalpy of fusion by temperature. So change enthalpy, if you want, it is delta H. Fusion is the enthalpy of fusion at constant temperature. Because we know that when solid changes into liquid and temperature does not increases, because there is a latent heat used to overcome the force of attractions between the molecules of solids. So this happen at a constant temperature. So this is del H fusion is the enthalpy of fusion at constant temperature and pressure also. Temperature and pressure. So here the process, because energy is absorbed, so del S fusion is always becomes positive, means entropy increases. We can say that in this case entropy increases because solid changes into liquid, so randomness increases. So we can say that del S fusion is positive, means entropy increases. Let's discuss the entropy of vaporization. entropy of vaporization. It is equal to the change in entropy when 1 mole of liquid changes into 1 mole of the vapor at its boiling point, So liquid changes into vapor and vapor again changes into liquid. This is the reversible process. So here del S vapor, change entropy vapor is depend final minus initial. Final means S vapor minus S liquid, or change enthalpy of vaporization by T, where del H vapor is a light fusion, del H vapor is the enthalpy of vaporization. Enthalpy of vaporization at its boiling point. At constant temperature, at constant temperature and pressure. At constant pressure. So here del S vapor is also positive, means in this case entropy also increases. Next is the entropy of sublimation. Entropy of sublimation. So number 3, entropy of sublimation. It is equal to the change in entropy when 1 mole of the solid changes into 1 mole of the vapor, changes into 1 mole of the vapor at constant temperature. At constant temperature. Entropy of evaporation takes place at constant pressure and entropy of sublimation takes place at constant temperature. So solid changes into vapor, change entropy in case of sublimation depends S vapor minus S solid, or we can say that change enthalpy sublimation by T. Here del H sublimation is the enthalpy of sublimation, enthalpy of sublimation at constant temperature constant temperature and pressure. So del sublimation, del entropy sublimation is also positive because changes into vapor form. Here entropy also increases. Entropy also increases. So do one questions based on this. Calculate the entropy change involved in the conversion of 1 mole, that is value given 188, of solid ice at 273 Kelvin to liquid water, and latent heat of fusion is value given 6025 joule per mole. So try to do this question, which is based on the phase transformation. Simple question: how can we find out the entropy change, conversion of 1 mole of solid ice to liquid water? Simply latent heat of fusion is given. Formula, based on the formula you can solve it. Now next, on the basis of entropy change, note down the second law of thermodynamics. Second law of thermodynamics. As we have discussed, change entropy in system equal to Q reversible system by temperature of the system. In case of change entropy in surrounding, Q reversible surrounding by temperature surrounding. So we already discussed change entropy, total entropy change is equal to system plus entropy change surroundings. So on this basis, it is clear for every spontaneous process, the total change in entropy is change entropy system plus change entropy surroundings is always positive. So we can say that change entropy total is always greater than 0 for a spontaneous process. The process takes place spontaneously, or we can say that change entropy total is positive for a spontaneous process. This is the second law of thermodynamics. So that's enough for today. In the next video, we will discuss about the Gibbs free energy. So